Hi, it's Tom with Heritage Electrical. So in this video, something a little bit different. I would like to take you through what a condition report entails, the sort of pieces of information that you'll find in a condition report. I would like to talk about some of the tests that we do and try and explain them in layman's terms, so that if you do end up getting a condition report, rather than just looking at a load of ticks and random regulations and test results, you might be able to understand a little bit better some of the information that you receive. And I would like to compare a condition report that we've just completed recently for a customer versus the one that they received a couple of years ago when they were first purchasing their house. Compare the prices that they paid for that one versus ours and the level of detail that they've received. So if we start off, let's take a look at some of the basic information that you'll find on the first few pages of the condition report. So we use a piece of software called EasyCert to complete our condition report. So this is the sort of standard format that the software will kick out for us. We can export it as a PDF and then send it over to the customer. So let's just go from the top. Obviously, there'll be the details of the property, the address, the name of the customer, specific reasons, if any, for compiling the report. In this instance, Paul recommended that we go and do a condition report of this property because he attended an emergency call out where there'd been an electrical fire. And that's because there were some non-fire rated downlights with some very hot running halogen lamps in there, and the customer had put in insulation without any sort of fire hood or replacing the fittings for fire rated fittings, and so that almost caused an electrical fire. Burned some of the cabling, so we recommended a condition report after that, and this is where we are. Now, details of the installation. Installation address, as I've mentioned, we estimate the age of the wiring system. Sometimes that's based on the colours, or if it's really old, it might be older style cable with smaller CPCs or earths in them, that sort of thing. Our job when we're compiling a condition report is made much easier if we have a previous report to go off. That means that maybe we can, if that previous report was thorough or seems to be thorough and authentic, then we can maybe sample a little bit more some of the circuits, some of the accessories on the circuits, to make our job a little bit quicker and perhaps a little bit cheaper for the customer. However, 99 times out of 100, we don't have any previous reports or any installation records to go from, so we end up doing an exhaustive inspection and test of the entire property, and that includes every socket, switch, lighting point, any permanently connected pieces of equipment. We maybe don't take off all the plates and inspect behind them, but certainly a number of them, and we certainly test each one so that we can get a full appraisal of the entire installation. Extent of the installation covered by the report. Sometimes there's multiple consumer units, distribution boards. Sometimes, as in this case, there's a solar PV aspect, but because this has been disconnected because the customer's having a new roof put on, we omitted this from the testing. So that's just details of exactly what we've tested there. Limitations. Now, in a perfect world, we would have an unlimited amount of time to carry out every single test as is written down in the literature that we go from, namely the guidance notes. There's one on inspection and testing, written by the IET, who produced the wiring regs, which is our Bible. They do one specifically on inspection and testing. In most cases, however, we are generally limited to a day or 2 days, depending on the size of the installation. So some of the tests, specifically with lighting, rather than disconnecting any downlights or all the downlights, removing all lamps, sometimes we will we'll come on to this in a wee while, but insulation resistance, which is where we test the integrity of the insulation of the cable. When it comes to lighting circuits, there's a combined test that we do rather than tests between each individual conductor, but we'll talk about that a little bit later on. So on the front page, you will get basically a yes or no as to whether the installation is satisfactory for continued use or unsatisfactory. Now, you can see there it's written in capitals and bold. It says unsatisfactory in this instance. Now, it's a little bit like a driving test in that if we compare the different codes to majors and minors like you would have on your driving test. So if there's any further investigation, C1, which is the most dangerous code, or C2 codes, C2 being potentially dangerous, then that is a fail. So anything which requires further investigation because of poor test results, or any of the two most dangerous codes, any one of those, and that returns an unsatisfactory result. Minors, we're calling those C3 codes, and a C3 code it's not immediately dangerous, it's just not up to current regulations, and at some point it needs modernising to bring it up to current regulations. So an example of that might be that you have an older consumer unit that's made out of plastic as opposed to the newer ones that are made out of metal. New consumer units need to be made from metal, and so that goes down as a C3 code. Not inherently dangerous, but just needs upgrading. A C1 would be live parts are immediately accessible. So that's immediately dangerous. An example of a C2 might be, let's say there's no earth to the building. For whatever reason, the main earth has been disconnected. It's not immediately dangerous now, but in the event of a fault, that would become very dangerous very quickly. So that needs rectifying as soon as possible. Recommendations. Providing that any remedial action recommended has been carried out and the installation is up to scratch. The guidance, and it is guidance, it's not a requirement from this book. And bear in mind, in this video, we're talking principally about domestic installations. There is different guidance for commercial and industrial premises, and depending on what those commercial and industrial premises are used for, the recommended intervals for testing will be different. But in the case of domestic homeowner properties, rather than tenanted rental properties, the maximum interval is recommended being 10 years. However, where we get, maybe slightly poorer test result readings, even though they might be within parameters required, we still recommend sort of every 5 years, or if there's a change of ownership of the property, as a rule of thumb. So that's your first page, a bit of a summary. This is where things get a little bit confusing for the layman who hasn't had any formal training in any of this. We get on to a series of observations. So this is like a summary of observations and recommendations for action. So you see in this instance, there are quite a number of, there's no C1s, so there's nothing that's immediately dangerous that needed rectifying, but there's a number of C3s and a number of C2s. So the C3s, just to give you an example, again, this probably doesn't mean anything until we have a look at it later on. But there's a main bonding conductor that connects other services, gas, water, oil pipework, things of that. There's essentially an earthing conductor that connects all these exposed bits of metal back to the electrical installation. So if there's a fault, there's not a big difference in voltage between, say, a metal socket plate and the copper pipework that's attached to your radiator. So if you touch both simultaneously, the shock risk is minimised. Now, because there's one conductor going between the gas pipework and then onto the water pipework in this case, it needs to be a continuous copper cable. In this instance, it wasn't continuous, it was jointed. Now, according to our guidance, and I'll just introduce you to another book that we use at this point, according to our guidance, that has to go down as a C3 code. So even though everything's connected together, because the cable's not continuous, that needs looking at and upgrading at some point. So when we are carrying out our list of inspections, I like to make use of this book called the EICR Code Breakers, which is produced by a company called NAPIT, which is a competent persons scheme. So for every possible observation that we make on the list of inspections, there's guidance on sort of how to code these. So rather than it being a subjective interpretation of the observations, we try and keep it consistent across the board. So let's take that as an example. So let's look at the section on earthing and bonding arrangements. So 3.7, condition and accessibility of main protecting bonding conductor connections. So like I said, that's the copper cable that joins gas pipework, water pipework, things of that nature, back to the electrical installation to protect you in case there's a fault. And here it says common main protected bonding conductor for installation, not continuous. And it gives me a C3 code there. So I, go off this, where there's any sort of grey area where I'm not entirely sure how to code something, I'll look to this book to see if it's got guidance in it, and then, we'll go with that. Now what you'll also see here is a big long list of numbers. And these numbers relate to regulation numbers in the Bible that we have here, which is the IAT wiring regulations. So everything comes back to this. This itself is written to allow electricians to be compliant with legislation. So this is not a legal document, it's just guidance on how to adhere to legal documents such as the Electricity at Work Regulations, 1989, and things like that. All these other books, and in fact, let's just show you another one that we like to use, the On-Site Guide, which is sort of a condensed version of the wiring regulations and the building regulations. All of these books are sort of extra information extra to the wiring regs. So these, like I say, these are sort of like, just sort of give you a little bit extra information in addition to what you'll find here. And they just make the regulations a little bit easier to sort of digest and interpret and action. So already you can see, from the outset of this video, there's a lot of literature that we need to sort of ingest, interpret, and then we apply that to our list of inspections. Let's move on. So you see there's a few C2s and C3s here that need action. Now the next page gives details on the test instruments that we use to complete our tests. So our test instrument, multifunction testers we use more often than not, which incorporate technology for us to allow us to perform all the tests that we do in one unit. These test instruments are calibrated and assessed each year to make sure that they remain accurate in the test readings that they provide us. And we also have other test boxes so that periodically throughout the year we can just ensure that they're still giving us accurate readings. So we need to note down information about the supply characteristics and earthing arrangements. So your electrical installation will have an earth to it. We'll talk about the earth fault loop path in a little while. But there's different ways that your electrical installation can be earthed. Now that's not really something for you to worry about. When we carry out our tests, we will note down the type of earthing arrangement. So we've got TNS, which is slightly older technology, I suppose, for earthing a building. We've got the slightly newer TNCS, which is the one that we predominantly see in most buildings that we go and test. And then we've got TT, which is perhaps in rural areas where the electricity supplier has not provided the building with an earth, then when the electrical installation is installed, the electrician will need to provide an earth, and that's usually by driving earth rods into the ground. So we note that down. That will then inform us of certain values that we need to measure when we're measuring the earth fault loop path back to the transformer in the street. More on that in a bit. More often than not, like I said, this video is about a domestic electrical installation condition report. It's going to be single phase. If you've got a factory or a commercial premises, something like that, probably be 3-phase, which brings more power into the building. We've got the voltage of the supply. Again, this is usually going to be 230 volts. We take other measurements such as the fault current, where your electricity, where your consumer unit is, and what we call the earth fault loop impedance, which is essentially a resistance measurement back to the transformer in the street. We've got the main cutout fuse, so details on that, the type of fuse it is, and the short circuit capacity and the rated current. So typical values for this: 60, 80, or more commonly 100 amps. However, we don't pull the main cutout fuse out and take it to bits and have a look to see what size the cutout fuse is when we are carrying out a condition report. So in this case, I've just put not verified.